Hello, and welcome to ASME's Robotics for Inspection and Maintenance Summit. And thank you for attending Optelos' webinar, Unlocking Insights from Your Inspection Data. I'm Ed Stuka, Chief Revenue Officer with Optelos, and I look forward to sharing with you today some of the things we've learned in working with our customers across several industries. I'll be covering the challenges they faced and how they've been able to utilize the Optelos platform to overcome those challenges. We'll also explore how all of your asset data, especially the emerging data from drones and robots and other sources, can be used to drive more informed business decisions and improve your overall asset inspection program. During the webinar today, we're going to talk a little bit more about Optelos, talk about some of the companies we work with, and how we help them solve some of their toughest asset inspection challenges. We'll also talk about the challenges the industry faces in general in utilizing all of these new data sources, how to leverage those data sources, and how to unlock insights from those data sources. We'll talk about some specific use cases, tell you a little bit more about the Optelos platform in general, and we'll wrap it up with some overall benefits and a summary of the discussion. So first, a little bit more about Optelos. Optelos is an enterprise platform with a unique combination of data management, visualization, and analysis tools that allow you to unlock the power of your inspection data to drive new actionable insights. Optelos has been privileged to work with many large enterprise customers across several industries, including energy, telecom, and industrial manufacturers. We also work with many large maintenance and inspection service organizations, helping them deliver better results to their customers. Our customers trust us with over 430 terabytes of their critical asset inspection data, and we help them achieve better results with their asset inspection programs overall. We've had the opportunity to work with many amazing customers, and we consistently hear 4 key goals that leading companies have for their asset inspection programs. Number 1, inspect more often. Drones, robots, crawlers now allow a near continuous flow of asset inspection information. Leverage all data sources. Visual data, design data, IoT data should all be correlated to improve the overall analysis. Digitize your assets. Go beyond standard engineering drawings. Utilize digital twins to look at the most current state of your assets in the digital world. And of course, apply analytics and change detection for predictive analysis and uncover new insights. So how do we achieve those goals? Well, there are some challenges to deal with. First of all, we have to deal with all this emerging data. If you're collecting visual data today from drones, robots, and other sources, you already know that you've got a mountain of data to deal with. More data, more often, and also a variety of data types: thermal, LiDAR, video, photogrammetry. Bottom line is the existing processes just don't handle all that data very well. And they can't make the most simple decisions of show me assets with corrosion or show me assets with other critical performance conditions. So there needs to be new systems in place to handle this challenge. Another huge challenge is managing, correlating, and allowing collaboration around the collected data. The problem with existing processes is that all these various data sources tend to go into their own data silo. IoT data likely goes in one place, drone data likely goes in another place, and data from other sources or crawlers or robots likely goes somewhere else. Once that happens, it's nearly impossible to make effective use of all that data, resulting in gaps in business intelligence. So what needs to happen to overcome those challenges? First of all that data needs to be centrally managed. You need to allow all those data sources to come into one place so that they can be appropriately analyzed. The other is that you need to eliminate those data silos through that centralized data management system. Allow that data to be correlated and allow proper collaboration across your organization. And ultimately, you need to be able to correlate that visual and non-visual data to uncover new insights and improve the end-to-end inspection process. And that's where Optelos plays a critical role. Very simply, the Optelos platform can ingest any inspection data source, and then through our patented core, transform that data into a single digital asset database. This eliminates those data silos we talked about and allows all those data sources to be utilized. The Aptellus platform then allows that data to be viewed in a variety of different ways. The platform provides the ability to create digital twins and allows all that data, thermal, LiDAR, videos, 2D, 3D models to be viewed and analyzed with a rich set of tools within the platform. The other thing Aptellus has done is operationalize the end-to-end AI development and deployment process. This allows AI to be put to use as needed. And of course, the platform seamlessly integrates with your internal EAM, ERP, dispatch, and trouble ticketing systems so you can enhance your end-to-end process. So let's dive into the Aptellus platform a little bit more. One of the most important aspects of any asset inspection program is the ability to manage the vast amounts of visual data being collected and easily share that data with all stakeholders, both internal and external to the organization. The Aptellus platform provides a flexible data hierarchy, allowing asset data to be easily managed in what we call work packages. These work packages contain a variety of functions that can be used to manage workflow, manage a variety of user privilege levels, store documents, store visual imagery, store videos, as well as support a variety of data compliance features. Data can be organized across facilities, across asset types, or across organization functions like operations, environmental health and safety, or inventory. Aptellus's patented geovisual capability allows all imagery to be geolocated, providing accurate geomapping of your data and facilitate a host of analysis and visualization capabilities. A feature called FlyView allows all drone path data to be mapped, providing accurate geolocation of all assets. Additionally, high-resolution video, photogrammetry, or other visual data can be tagged to specific geolocations as well. This allows detailed asset inspections to occur and direct dispatches to exact locations. Aptellus also offers a variety of 3D capabilities. We create 3D point clouds or digital twins within the system with accuracy to 1 centimeter. This allows detailed analysis to be performed on the assets for a variety of planning, inspection, and construction purposes. Detailed analytics can be performed, and all associated pertinent data related to the asset can be assigned to the digital twin. This allows organizations to rapidly assess required data and make the most informed decision using all available data sources. As I mentioned earlier, Aptellus also supports what we call the operationalization of AI. On the front end of that process, data scientists or domain experts can access collected data to develop AI models to ultimately automate and streamline any given inspection process. That process starts with labeling and annotation of the collected data to create what we call labeled data sets. It's these labeled data sets which identify acceptable and unacceptable conditions that are used to create the AI models. Once these labeled data sets are created, they are used to develop the actual AI model or classifier. Aptellus can develop those AI models for our customers, or our customers can export those labeled data sets to any third-party AI development tool of their choice, such as IBM Watson, Microsoft, TensorFlow, or others. Once that AI model is developed, it can then be deployed back within the Aptellus platform to process newly collected images and complete that end-to-end workflow, thereby streamlining and automating any inspection process. Once that AI model is deployed within the Aptellus system and being used to process newly collected data, the integrated trouble ticketing system then comes into play. This allows any defect or condition that the AI model identifies to be turned into a trouble ticket or dispatch event. Let's say, for example, visual data collected by a drone is used to identify a fault condition on a power line. When a fault condition is identified by the AI, it will automatically create a trouble ticket. All the data associated with that fault is then attached to that ticket, including the exact geolocation of that fault, streamlining the inspection and mitigation process. Now that we've covered some of the basic functionality of the Aptellus platform, let's apply some of that functionality to a few real-world examples. As we look at these various applications, we're going to take a look at the data types that are utilized, the analysis methods within the Aptellus platform, the insights that can be obtained, and what sort of outcomes are really being generated. For something like asset changes over time, the data types utilized could be thermal, spectral, standard photogrammetry. The analysis methods within the Aptellus platform will focus on the ortho-compare and multi-ortho overlay feature. And of course, the insights here would be around asset degradation, vegetation encroachment, preventative maintenance, and others. The outcomes that would be achieved here would, of course, be improved asset performance, reduced downtime, and, of course, environmental health and safety improvements. So a common inspection challenge is identifying asset condition changes over time. Perhaps this is a condition like corrosion, or maybe the issue manifests itself in a thermal profile. In any case, this is the perfect application for the ortho-compare feature. Images can be collected on a regular basis, and these images can be constructed into a 2D orthomosaic model. We can then compare those models over time or across various data formats to easily identify changes. This, of course, yields improved asset performance, reduced downtime, and reduction of safety or compliance issues, all yielding significant benefits. The next application we'll take a look at will be around environmental health and safety improvements. Here we'll look at various data sources, LiDAR and photogrammetry primarily, and we'll take advantage of some of the 3D modeling capability within the platform. The insights here will really be around more frequent inspections, around hazardous assets, and the outcomes are really around improved safety and improved inspection quality. A particular challenge for many companies are the environmental health and safety issues associated with high-risk inspections, such as placing inspectors in confined spaces. The advent of drones, robots, and crawlers reduces that risk significantly and allows inspections to occur more frequently. The Aptellus platforms allows live streaming of those inspections, so domain experts can assist in real-time analysis. Similarly, 3D models using LiDAR can be used to see through tanks and other assets to perform accurate measurements of these assets without manual intervention, all contributing to a safer, high-quality inspection process. The next application we're going to look at is around facility maintenance. Here, a variety of data types can be utilized. We're going to look at what can be achieved through standard photogrammetry, using digital twins and measurement tools as the analysis method. The insights that will be gained are really around the detailed measurement capability of those models, and the outcomes are reduced planning costs, inspection costs, and reduced labor costs associated with those facility maintenance inspections. Facility maintenance inspections are, of course, one of the most common applications of unmanned visual inspections today for performing routine facility maintenance. Once the site or asset is flown using drones, detailed 2D and 3D models can be built. Since these models are highly accurate, they can be used for construction planning, perform visual inspection of assets, assess asset integrity, and more. These models or digital twins then serve as the basis for future inspections as well. This approach tends to yield significant savings in capital expense, manual labor, and significant reduction in inspection cost and time. As I hope you've seen throughout this webinar, the benefits achieved by unlocking the power of your asset data are pretty significant. First, you can realize immediate efficiencies, cost savings, reduced labor, and reduced capital equipment through your inspection process. You can better identify and prioritize work activities to address the most critical issues. You'll achieve improved safety and enable more continuous inspections at lower cost. And you continuously increase insights of your inspection program as your program continues to grow. In closing, Optelos is focused on helping you transform your asset inspection process and unlock the power of your data. We make data your most valuable asset by transforming and infusing it with insights beyond human inspection. We allow you to control your program by standardizing the data management and AI workflows, putting you in control. We can integrate with your existing support systems like SAP, ServiceNow, and trouble ticketing systems for a seamless end-to-end workflow. And as demonstrated, we can operationalize AI across your entire organization. This allows you to start and scale your AI program to fit your needs. So regardless of where you are in your digital transformation journey, Optelos is here to help. I'd like to thank you for your time today. I hope this session was valuable. Please take some time to review the materials in our virtual trade show booth, and please contact us with any questions. We would love to learn more about your specific challenges and how we can help you achieve your asset inspection goals. Thank you.